computer. All right. Welcome to Doc Waller's Earth and Space Report for Friday, May 31st, 2024. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on a pleasant spring evening in my hometown of Rockport, Massachusetts. These Earth and Space Reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life-sustaining biosphere, and who wonder about the greater cosmos and all that it has engendered throughout space and time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. They are also in regular rotation on Cape Ann's community access cable television channel hosted by 1623 Studios. I am grateful for the continuing interest and support shown by Rockport educators and students, Cape Ann cultural colleagues, cohorts of the Gloucester Area Astronomy Club, sundry Earth and space scientists, educators, and communicators around the world, far-flung friends, family, and other curious folk. Thank you for your active participation, comments, and general encouragements. This episode follows April's solar eclipse Sharathon, where folks recounted their experiences of viewing the total solar eclipse on April 8th. Hold on, I gotta get Igluki in. Okay. For this evening, we will continue our communing with an Aurora Sharathon that will feature personal experiences of the amazing auroral activity that graced many skies on the night of May 10. I will get things started by providing some scientific background, followed by my own experiences of viewing the aurora from near my home in Rockport. We will then move on to other folks' experiences, culminating with a showing of the wonderful movie that Jeremy Parker has made. So let's get going. I will first share my screen and begin my slideshow. So here we go. So share the big one. That was the mistake that I made last time. And slideshow from the beginning. Okay, Aurora Sharathon, when the sun blasted Earth. And I will make sure that, whoops. There we go. Okay, Aurora Sharathon, when the sun blasted Earth on May 10th, 2024. And so this is a picture I got off the internet, which was full of them. The astronomy picture of the day has a whole archive of wonderful aurora pictures. And I just thought this one looked pretty good for my title page. All right. And so I'm going to begin with something that I showed in a prior presentation. I think it was at one of the Gloucester Area Astronomy Club presentations on Aurora. But this one is, it's a little video which shows the influence of the sun on the Earth's upper atmosphere. Turns out the influence is not just on the atmosphere, it's also in the on the ground. The ground develops currents. Okay. All right. And I might as well make it big.
Our sun is constantly blasting huge amounts of hot plasma out into space. All those charged particles have a big effect on everything in their path. So what's protecting Earth from the solar wind and solar storms? Earth's thick atmosphere provides some defense, scattering and absorbing solar particles before they reach the surface. But our planet also has a secret weapon, a strong magnetic field that projects into space, mostly generated by molten iron alloys moving in Earth's outer core. The area of space where the magnetic field interacts with the solar wind is called Earth's magnetosphere. Its shape constantly changes as it's bombarded by solar particles. As positively charged protons and negatively charged electrons enter the magnetosphere, most of them are deflected around Earth, long before they reach the atmosphere. The magnetosphere really gets tested when big solar storms, carrying more plasma and traveling at higher speeds, are on a collision course with Earth. While most of the plasma is deflected, some of it gets trapped in the magnetosphere and funnels back toward Earth along field lines emanating from the poles. As charged particles from the sun collide with nitrogen and oxygen molecules in our atmosphere, they create the cosmic light shows known as auroras. The bigger the storm, the further from the poles auroras can be seen. Some storms are so big they interfere with satellites, cause planes to alter their routes, and can create other problems. The vast majority of the time, these inconveniences are pretty minor, but the next time the solar version of a perfect storm overwhelms Earth's magnetic shield, we might not be so lucky.
All right. Okay, I want to
This Thursday.
stop this and escape. There you go. That's what I want to do. And then I want to get rid of this. And so we're good. So for people who like to sky gaze, that would be lucky. It would be nice if we could see more of these events. And it's worth noting that the charged particles, namely the electrons that bombarded our side, the night side of Earth, originated here in the magnetotail. And so it's not even clear whether it's the same electrons that came from the sun, because the magnetosphere, once disturbed, can produce its own currents of electrons. Just a little side note there. It's hard to tell what actual particles bombarded our upper atmosphere and produced the corona. Okay. So the classic aurora is a two-tiered event, mostly. It emits green colors at lower altitudes and red colors at higher altitudes, as seen here. This is a view from an airplane. So you're heading into the stratosphere, but the aurora actually occurs even higher in the thermosphere, beginning at around 100 kilometers and going up into around 200 kilometers. But this is kind of the classic auroral display. And it's been understood for some time now that the aurora is produced by spectral line emission from excited oxygen atoms due to the bombardment of the electrons on these oxygen atoms. And that explains most auroral displays. You get the green emission at 5,600 nanometers, and then you get the red emission at around 6,300 nanometers. There's also sometimes additional colors from nitrogen, and most notably this purple. Okay, and the nitrogen is in molecular form, especially ionized nitrogen molecules, where one electron has been ripped off of it. So these atoms get excited. Atoms and molecules get excited. The electrons in their orbiting, in their orbits, move to excited levels, and then when they return back to their less excited levels, they emit these very characteristic colors. And several of you shared this graphic, which is rather nice, and it sort of explains it. Here you have the classic situation of the green, basically beginning at around 100 kilometers and moving on upward. And they say that it's due to the higher concentration of oxygen. Well, it's the higher concentration of everything, because the atmosphere gets less and less dense the higher up you go. And it turns out, I'll explain next why this can glow at relatively higher densities, and this can only glow at low densities. And in addition, I guess you can get ionized molecular hydrogen at even lower altitudes. Okay. So here's the quantum mechanics of it all. Just what you were looking forward to. Basically, this is the energy level diagram of electrons in the oxygen atom. And what happens is the electrons get excited. And if they get up excited to this state, they will eventually cascade back down to a lower energy level and emit the green emission. But they also, if they can also go down another step to emit the red emission at 6,000 angstroms or 600 nanometers. And this sort of explains, oops, wait a second. There we go. Okay. It turns out that how long they stay in these excited levels really matters. Now, the excited level that leads to the green emission, it only stays at that level for less than a second, which means that as soon as it gets excited, basically within a heartbeat, it cascades back down. But this level is more of a metastable level, and the electron will linger there for more than 2 minutes, 159 seconds. And so it is susceptible to being de-excited by collisions. And that's why you don't see the red at lower altitudes, because the probability of collisions at those higher densities is much higher. And so this level gets de-excited too much at the lower altitudes and higher densities. And so that's the theory, which explains why the red is only seen at the higher altitudes. Okay, so with that little background, here is what occurred close to May 10th. This is what the sun looked like on May 8th, and the very tight and enormous sunspot grouping called active region 3664 was responsible for a lot of the activity. This sunspot group, if I'm not mistaken, is 10 times larger than Earth, but Mario might be able to correct me on this. So this is what the picture that Mario took on May 10th, which was the big day, as imaged in H alpha. And so Mario, would you like to chime in on this and describe this image? I also have a close-up.
Yeah, sure. Can you hear me?
Yes.
So, unfortunately, I was at a meeting the night of May 10th and missed the actual aurora. I probably should have drove all the way back home. But that morning, knowing that there was a CME coming and knowing that there was a huge sunspot group, I took this with my 90 millimeter Coronado and then processed it in PixInsight. It's an H alpha filter. The spot, the one you referred to, by 2 days had moved over to the western limb, and
right.
that's the one that used that huge complex. And in my photo, you can see a couple of white spots.
I'll give
And
the
the
close-up.
the professionals were saying that that is micro flares. This thing was just popping off all over the place, because normally when I take pictures of sunspots, you don't see those intense white spots. So those were micro flares. So it was constantly shooting off energetic particles is what you're seeing. The below that is a really nice prominence group that has nothing to do with the aurora that we saw, but it just happened to be in the background as a innocent bystander.
All right. Okay. So this is the sunspot group that you can blame.
Yeah. By the way, it's come around.
Yes.
In fact, I took a picture of that same sunspot group today. It's on the eastern limb coming around again, and it gave off a CME just 2 days ago.
And they've given it a new number, isn't that correct?
I don't know if they renumbered it, but it's the same sunspot group.
Yeah. Yeah, so that's a very persistent sunspot group. Okay. Okay, well, what's going on here? All right. So here's the same sunspot group blasting out an X-ray flare rated at X6, which is way high on the energy scale. And I don't remember what day it was. Oh, this was the day of the 10th. This is universal time. So this would have been around the evening of the 10th. So that would have led to subsequent activity, which did not make as big an aurora. But it's pretty exciting. And here is one of several coronal mass ejections that headed our way. And it's kind of, oops, sorry, let's go back. You might see a lot of flecks. Those are actual particles that hit the detector. The LASCO coronagraph on the SOHO satellite. And it's because it was headed our way, the coronal mass ejection doesn't look that impressive to this going to the side, but that's because it was headed in our direction, and that's why we get all these particle hits. And this was like one of 5 coronal mass ejections. It was like a train that headed our way from this active region. And here was the aurora forecast, and it was the nuts. Usually it's just a very, just a little green band around the Arctic Circle, which is what it was last night. And but this went as far south as the Carolinas. This is a prediction, and actually they caught auroras off of Florida, and maybe some of an island or two in the Caribbean, and then in the southern hemisphere they caught in Australia and New Caledonia. This was a bruiser. So that's what it takes for me to see an aurora. I have to wait for the biggest ones. And so the National Weather Service provides a very nice website that gives you the information on what was happening on Earth. And they found that there was a geomagnetic storm on Earth at its highest level, G5. And here they were giving key messages on May 11th that there might be more activity. And they thought there might be some impacts on the power grid, but as far as I know, we were spared. Who's the guy with those annoying satellites? Elon Musk sent out a tweet saying that they were watching their satellites, and so far they had survived it. Now you may or may not be happy about that. So anyway, this was
It's
a
a shame
very,
they survived.
I'm sorry, Mario.
I feel it's a shame they survived.
Yeah, likewise. But they do have their, I guess, their advantages. There's people who can communicate in underserved areas. So, ugh. So they also provided views, God's eye views of the sun, releasing the coronal mass ejections, and then they spiral out because the sun is spinning, and then they hit Earth and also these 2 satellites called the stereo satellites, and it was probably those satellites that provided these data. And what really impressed me was the velocity of the particles. They're usually just a few hundred kilometers per second, but then beginning basically on the 10th Eastern time, they cranked up to 800 kilometers per second, and then all the way up to about 1,200 kilometers per second, and then here, this is their information. They said they made it up to 1,800 kilometers per second. And so those were very speedy electrons reaching Earth. And they gave, warnings that there would be a storm watch, geomagnetic storm watch through May 12th, and it'd be able to see stuff at lower latitudes. But it really was the night of May 10th that was the winner. You might wonder how they rate these sorts of auroras. And they have a probability rating. It's called the KP scale, and it goes from 1 to 9, and it made it all the way up to 9. So it was very high probability of seeing the aurora at lower latitudes. And so there in Wisconsin, Claudine Zenko happened to spot the aurora by the roadside, which had a road sign called KP. So that was pretty cool that she saw an aurora which was rated with a sign. Should have said KP9.
Bill, can I just interject? The KP index right now is about a 5, and it's predicted to go up to 6 or 7 by between 8 and 10 tonight. So when you finish your podcast, you might want to, everyone who's listening might want to go outside around 9 o'clock when it's dark enough. You might have an aurora tonight.
Yeah, which is, very exciting. So here on Cape Ann, the auroral activity picked up on May 10th, shortly after the monthly meeting of the Gloucester Area Astronomy Club, which featured a gal from the Center for Astrophysics talking about active galactic nuclei and their black holes. And so by the time that meeting was done, I walked out, and I noticed that I noticed there was a little haze to the north, and then I noticed that there were 2 members of the club, a father-daughter duo, who were looking towards the north, and one of them had a digital camera, and she took a shot, and the picture was green. It showed green. And so that just told me that there was an aurora developing. So I went home, drove the 2 miles to my home, and my spouse was already asleep in bed after a hard week of work. And so I left her and hoofed it to Point de Chêne, which is has an eastern and northern overlook, in fairly dark skies, as long as the houses turn off their outdoor lights. And this is what I saw. I used a digital camera, SLR camera, and 1 second exposures, handheld. And I'm not the steadiest person on the planet, but this is what we saw. We could see green, red, and violet colors, but it's not in the expected horizontal strata. It was more like in vertical strata, so that was contrary to the classical auroral display that I showed before. Sometimes the sky was dominated by just the green emission from the excited oxygen atoms at low altitude. I had it at a fairly wide angle, so this is a significant portion of the sky, maybe a little less than a quadrant, but it's a fair bit. And sometimes the sky was dominated by the oxygen emission, presumably at the higher altitudes. And then there was, I would say, I could see it naked eye, there were purple hues presumably from the excited nitrogen. Again, it was banded vertically rather than horizontally. These are clouds over here. And very similar photos were taken by Virginia Renahan from Granite Pier, about 2 miles south of Point Duchesne on Andrews Point in Pigeon Cove. So the amazing thing is that I could see the colors naked eye. And it was all in rippling motion, which I tried to capture with the by taking a movie with my digital SLR. That was a fail. But there was a gentleman next to me with his iPhone, and he was capturing everything in real time. I could see it on his screen. So, kudos to the iPhone people and perhaps to the Android people who made these sorts of capabilities with their cameras. And so if you have a chance to catch one of these Aurora, you might want to try your hand at using one of these fancy phones, especially if they have a dark setting. So that's it for my slideshow. I want to ask if there's anybody else who want to share their experiences. And going once, going twice. All right. So as I mentioned, I had a complete fail with capturing the Aurora with the movie mode of my single lens reflex. But Jeremy Parker, who knows what he's doing, did a time-lapse shindig, and I'm going to hand this over to Jeremy to talk about what you did.
Okay, great. Can you hear me?
Yes.
All right. Well, before I share my screen, I'll just tell you what I did. So I have a couple Nikon mirrorless cameras, which are probably not all that different than your typical digital SLR. Same idea. So I set them both up on tripods, and both cameras have what is called an intervalometer, it just means it can take pictures at regular intervals. So once you set your exposure how you want it, it will take them every whatever you specify. And then if your camera doesn't have that, you can buy them as an external device that plugs in and triggers your camera for you. So so the concept really is just to get the camera firing off at regular intervals and then just let it go. And that was basically what I did. So one camera had a fairly wide angle zoom lens. I think I had it set at its widest focal length, which I think was 14 millimeters. And then I had a fisheye lens. And that I had, well, there's no setting for that. It's a fixed fisheye lens. And so between the two, I figured I could cover most of the sky. And I didn't really know what I was in for. I basically started getting some exposures, got my focus, and just started to see some green. And I thought, oh, great, I'll get a little bit of green in the horizon and that'll be it. And, and I was almost going to just let it go and then, go back in the house or go to bed or something. But fortunately, I kept looking at the screen and it just kind of blew up in color, and I was very very excited. And so what my movie came from was basically a feature in my camera that takes each of those exposures and puts it into a video frame in a movie, and it can do that kind of automatically. Another way to do it is to take a bunch of individual frames that come from running an intervalometer, and then there are different programs. You could do it in Photoshop, but you can basically take each exposure and turn it into a frame of a movie. So did you have a question, Bill?
Yeah, what was your exposure times?
Oh yeah, so I believe they were 5 or 10 seconds.
Ooh.
and I think I was at an ISO of 1600 maybe. In retrospect, I probably could have had a longer exposure time or a higher ISO. I was a little bit underexposed, but I actually didn't really know
Mm.
what to expose for because I
Yeah.
wasn't sure I was going to get anything. So,
Yeah.
um, but yeah, so I took my footage and then I just did a little bit of tweaking in my video editor, and that's what I'll share.
And the music?
Oh yeah, and yeah, usually I compose the music for I always compose the music for my videos because it's just something I like to do, and I have a few astrophotography videos on my YouTube channel that I've shared over the years. So basically whenever I gather up enough images or footage or time lapses or whatever, I kind of string them all together and could be a 10-minute long movie and then write some music for it. But this one I just thought, well, I'll just do my 2 minutes that I got and I'll just put it out there because it seemed like it'd be a shame to wait until I don't know, another year before I share it or something. So yeah. All right, so I'll share my screen. And oh, let me make sure that my settings, let's see. I want to make sure that I'm sharing my audio. I forget. Bill, do you remember how to do that?
I think it's under the
Lower left-hand
under the
corner,
mute. Sorry, Michael.
lower left-hand corner checkbox.
Okay.
Select a speaker.
Of the white pop-up screen.
Let me see if I can maximize. Okay, now I can see, I think. Okay, so you said lower left-hand corner?
As I
Yes.
recall.
It's the dagger next to the mute.
Oh, same as system. Select the microphone. Yes, and I think
The white pop-up that shows you, let you choose the screen you want to share. It's on there.
oh,
Should it be leave computer audio? Is that that what you want?
leave computer audio. Well, why don't I try it?
Options on the right-hand side, they've moved it. Options, share sound.
Oh, let's see. Right side of where? Right side of
Of the
screen?
pop-up screen where you choose a screen to share. It's white. It's got an array of different applications.
All right, let me stop sharing because I'm not able to see that. So let's see. How do I stop sharing?
Reshare. Yeah, just
Yeah.
at the top. There you go.
Okay. Now share screen. Okay, why is it? Oh, okay. Share sound. Got it.
There you go.
There we go. All right. Thanks so much, Michael. Sorry about that. So can you see my screen?
Not yet. It says, oh, yes, yes.
Okay.
Beautiful.
Now, load the video. So yeah, hopefully this will just run here.
Great. wow, you nailed us with that last visual.
Well worth all the fumbling.
Oh,
Yeah.
good. Thank you.
Hey, Jeremy,
Yeah.
did you adjust your frames per second to match the rhythm of the music?
Not for the music so much, but just the interesting parts of the Aurora that were happening at the beginning and the end. I slowed them down to 15 frames per second from 30 frames per second. So at least for that beginning part with the 14 millimeter lens, that angle, yeah, I did adjust the speed of it to slow it down so it didn't go by so quick.
Well, it fit with the music really in an interesting way.
Yeah, I played around a little bit, but I mostly just knew how much footage I had and then kind of composed the music to fit in that space more or less. And then it just, whatever happened was a kind of happy accident, I guess.
You are not shown right now, Jeremy.
Oh
Just
no. Oh, start video.
there you go.
There we go.
Beautiful.
Sorry about that.
Yeah, just it's the feeling that I got in Point to Shane and that your movie portrays is just how overwhelming it was. I mean, it was all over the sky. You could see it to the south, for heaven's sakes.
Yeah, yeah.
And maybe the explanation for the vertical banding is that we were really underneath these curtains. I mean, who knows? I am yeah, I don't get to see these things often enough. But we were really in it.
Yeah. The only other time I've seen the Aurora was in Iceland a few years back. And most of the time, maybe I saw it on 3 or 4 occasions, and you could only really see the color through a camera, except one time when I was in downtown Reykjavik, and I was near the hotel where we were staying, and I was walking around and saw the activity start up again in the camera, and then all of a sudden it came on shore, and it was glowing above me as bright as the streetlights, and it was that vertical, yeah, curtains of light moving. That was incredible because that was super bright.
So I guess the recommendation, maybe including tonight, is that you get out there and if you don't see anything yourself, aim a camera and see what it picks up.
Yeah.
And if it shows green, then there might be some excitement.
Hey, Jeremy, where were you taking those photos from?
I live in Chelmsford, so pretty close to Lowell, so it's a fair amount of light pollution. So I was very surprised
It's
that I saw
amazing.
it. Yeah.
But this is
So I have a short Aurora tale if you have time for it.
we definitely do.
Okay, not this Aurora, but I did see one when we were in Maine on a, they call it the annual Frozen Toes Star Party. Everyone would go up to Maine in the middle of the winter. And there were like 10 or 12 of us in this big field somewhere in central Maine. I don't remember where. And all of a sudden, all this light pollution started moving in around the edges. So what the heck is going on with this? Just gray light, like somebody opened up a car lot, and then woof, and sheets and colors and the whole thing. You could have read a book, I'll bet, by the light from the thing. And the interesting thing, and the reason I'm telling you this, is because we must have had $100,000 worth of telescopes set up in that field, without a doubt. And it was like a Far Side cartoon with all this equipment lying fallow in the field and all of these amateur astronomers walking around going, ooh, ooh, ooh. It was amazing. Just the circumstance of it.
Could you tell us the approximate year?
That would have been late 90s.
Oh, late 90s. Because the last big one, which I think my spouse saw with our kids, was 2003. So you're saying late 90s.
Yeah. That's when I was active in NSAC.
Oh, yeah, North Shore Astronomy Club, Amateur Astronomy Club.
Yeah.
Yeah. So wouldn't it be great if we had more tales to tell?
Well, I have
Well,
one similar
The
to
caveat is it ruins a good observing night.
Yes, you don't want to live up there. Richard, what?
well, I have a tale kind of like yours, Bill. I was with you up there in Lanesville when we went out from the meeting and looked. So I got in my car and I raced 2 miles the other direction from you to my house and first detoured out to the ocean, a block from my house. So I'd get a, perfect view to the north and east, etc. And I said, wow. So then I raced back to my house. The lights are all out. I went up, my wife is sound asleep. I shook her awake. I said, get up. You know how much it would cost for us to go to Iceland to see this? You can go and see it in the driveway.
So you got her up.
That was fun. And
Yeah.
I'll donate all those savings to the Gloucester Area Astronomy Club.
That's right. Big donation.
Right.
All right. So I guess we'll all have to stay up a little bit tonight. We'll see
I
what's
got a
what.
couple of questions if you don't mind.
Yes, all right.
This is a coronal mass ejection. So what's the corona made of in terms of material?
Ions. That's why they call it a plasma. It's atoms which have had. It's so hot that they have their outer electrons stripped off because of the intense collisions with one another.
So this is a hydrogen atom that's got the electron.
Mostly hydrogen, a little bit of helium.
Okay, so the hydrogen is magnetically, or the electric field ejected from the sun. So you're talking about a plasma of an atom, but when we see it here on the Earth, it's an electron that is stripped off of something locally.
Right.
And
The
because
the light is coming from pre-existing matter in our upper atmosphere at 100 kilometers to 200 kilometers altitude. So it's the oxygen and the nitrogen in our own atmosphere. That's what our atmosphere is made of, mostly nitrogen and oxygen. But it's the electrons that either came from the sun or were trapped in the Earth's magnetosphere, which got a kick in the pants and streamed down towards the poles, but in this case, farther south.
See, that's why I'm confused, because when I was at work, I made a lot of plasma. We made plasma out of everything, arsenic, boron, phosphine. So you're ripping electrons off. In the sun, there's only one electron on the hydrogen atom. So you rip that off, and then you throw the hydrogen ion into our magnetosphere.
Right.
And there's no electron there to be ripped off of that hydrogen atom. It's already gone.
Oh,
So
it's still there.
combine-
The protons stream out
Well, the
and the
protons,
electrons
sure.
stream out. They're just not connected anymore.
Okay, so the electrons are kind of traveling also with the
Right. That's what a plasma is that
hydrogen.
it's
Well, the plasma is something less electron. Okay, that's what a hydrogen atoms consists of. One electron
right.
and the nucleus. So you rip off the electron, it's gone.
Both
now
of
you
them travel from the
Okay.
sun. And I don't know what happens to the protons, tell you the truth, but apparently it's the electrons that have the effect on the ambient
our
ambient
atmosphere.
atoms. Yeah.
Okay.
Well, it's the electrons hit us in the northern hemisphere, but the protons get attracted to the south pole.
Oh, wow.
So
Oh,
that
right.
the Aurora Australis is a proton influx. The Aurora Borealis northern is an electron influx.
Are the
In a few
colors
years,
different?
when the
Didn't know that.
magnetic field of the Earth will flip, well, that'll be backwards.
Are the colors different?
They should
What's
not
that?
be different. It's the same composition in the atmosphere, the
Yeah,
oxygen.
the mechanism is the same. It's the oxygen and nitrogen being stripped, and that can occur from an energized proton or an energized electron.
Ah,
Mechanism is the same.
thank you for that explanation.
You're
But
a
it's
plasma
upside
guy.
down there, so the colors would be flipped, right?
Colors will be flipped.
It's like the toilet swirl the other way in Australia.
Yeah, yeah.
The water goes down the drain because I was there and I checked. Working at Varian, we make ions. That's the business. It's an ion implanter. It strips electrons, single charge, double charge, triple charge off of arsenic, boron, phosphine, nitrogen, oxygen, helium. We just make ions to implant into silicon.
Mhm.
So I made a lot of plasma.
Our plasma guy.
Yeah, yeah. And at 100,000 or 180,000 volts.
Yeah, you're lucky to be alive still.
It's interesting.
I have a follow-up question for Mario. If it is protons for the Aurora Australis, are the colors different? Are the energy levels that are the the atmospheric gases are impacted with different or
No, it looks exactly the same down there as it does up here. Again, Bill's explanation of why we get the colors is the same. It's the electrons in the oxygen that is stripped off, and then the electron shells drop.
And
The
the
energy
energy
comes from the ion striking them.
yeah, it's fascinating.
Hmm. Always something new.
This made me think of one of my favorite physics stories, which is cosmic radiation hitting our upper atmosphere and creating muons, and they're very, very short-lived. Only they make it all the way down to the surface of the Earth because they're traveling so fast. They're traveling at relativistic speeds.
Hmm.
They're traveling so fast that their time is slowed to the extent that they actually travel that distance. If there weren't time dilation, they'd travel a few hundred meters, and that's their half-life, their decay rate. But they make it all the way down to the surface, it's just the sort of amazing built-in, easy to digest, verification of special relativity.
Hmm. Wow.
Trying to show you the KP index. It's lower than it was predicted right now. Right now, it's a 3. In an hour or two, it's supposed to go up to 4.8. Yeah, initially it said it was going higher, but then it seems to drop off after that. So it's iffy right now. But that may change. It changed from the last time I looked at it.
Well, the worst thing that can happen is a clear sky for observing the other stuff.
That's great. When I had a place in New Hampshire, an observatory up there that Annie Hendon now owns, I think it was 99 or 2000. There was just seemed like endless auroras. And I'd go up there to take astro photos, and every time I'd have this aurora light pollution that ruined my night. It got to be annoying because it was so much at that time.
And of course, where the auroras tend to be farther north, the light pollution from just the summer sky starts hitting. I asked somebody in Alaska if he could give a presentation on the aurora he saw, and he says, "I didn't see any aurora because it was too light out."
Because the interval of nighttime is so short up in
Wrong season. So, well, I think we've done very well here. We've certainly, I think, made the bed for the next Aurora to come by. And I look forward to us getting together again on this topic.
Well, thanks, Bill.
Yeah.
This is
Thank
Great
you
lecture.
all.
Thank you very much.
Okay, take care and well wishes.
Good night.
Hey.
Thanks. Bye,
Thank
everyone.
you. Nice job.